All right. So in testing, there are a couple of different ways of testing. One is manual testing. The other is automated testing. Okay. Manual testing means manually you are clicking, you are verifying the web page is working as expected, or whether the web service is working as expected. So, I mean, as we discussed in the previous sessions, let's say, let me put this section. Let's say this middleware, you have front end, back end, right? So you might have this kind of setup. Yeah, so kind of like this. Okay, so you have front end, which is a browser based. You have a maybe React or maybe Angular, whatever the framework. So you might be interacting with the front end. Okay, so the front end can be anything. Okay, so it can be HTML, CSS, JavaScript, Qt, QML, or it can be Java, C Sharp. So a bunch of things on the front end side. Okay, or VB, very old VB and all that. Okay. And then on the middleware, you might have services like REST API services. It can be Python, Java, and so on. Okay. On the backend, you will have databases. But yeah, so this is like a very high level, like almost like a 50,000 feet picture. Now, there are different testing. I mean, you want to test your front end, you want to test your middleware, you want to test the database, and all these things. Okay. So there are different things. Manual testing, let's say you are doing front-end manual testing. You are verifying the web page is working as expected. You're going to look at different text widgets. You're going to look at combo boxes, check boxes, whether they are working as expected or not. So you're going to do a bunch of clicks and going to verify and all that. Okay. So that would be like a manual testing. Now, when it comes to automated testing, the same thing that you're going to do manually, like clicking on buttons, verifying the text is visible or not, all those can be done programmatically also. Okay, so I can use Python, I can launch a browser, and I can say, hey, show me this particular web page, and I can say, is the button visible? What happens if I click on the button and all that? Okay, so all that can be done programmatically also. Okay. Now, when it comes to middleware, last time we saw Postman. Postman is a manual testing tool. Okay, that means you are opening up Postman, you are saying get request, post request, or put request, and so on. Okay, so that is a manual testing, but we can also automate that. That means Python can send this get request, post request, and so on. Okay, so there are different libraries. We can make a request and we can get the status code, we can get the response body values and all that. Okay, so that is programmatic way of getting the data and then verifying. I mean, what is the status code that I got? Did I get a success? Did I get a failure? And so on. Okay, so that would be programmatic, and this would be called automated testing. Okay, now what is the advantage of doing automated testing? The advantage is that if I write the code once, I can run it 100 times. Okay, so I can run it every day. Okay, so if I do manual testing, that means manually somebody has to test it every day, and it's a lot of manual effort involved. Okay, so imagine there's a lot of functionality. Let's say there are 100 websites or 100 web pages. It's not practically feasible for one person to test all these 100 different web pages and so on. Okay, and if you want to test multiple times during the day, that means the company has to hire multiple people, and there might be complex workflows. I mean, there might be some configurations. Let's say there is a European specific product, there's a US specific product. The person has to be really knowledgeable. The tester has to be really knowledgeable to know those configurations, those settings. How does the website change based on the location and all that? Okay, so but if you are automated that code once, I can run it every day. Okay, that means it's pretty much the program is running and you are verifying the website is working as expected. Okay, so the advantage of automated testing is that you're going to cut off the manual effort, and it's possible to find more bugs, or you have some confidence in your code base. Okay, all right, so that is my automated testing, and let's look at some I would say some libraries and so on. But before we jump into libraries, I want to show you guys some object-oriented programming of Python, also some functional style, and then we're going to use those. Hey Teja, I'm going to record this and I'm going to upload this into the YouTube, so you don't have to record. Okay, so I'm
Okay.
going to deny this for now. Okay.
Okay.
Yep. Okay. So yeah, so so pretty much that we're gonna look at functional style and object-oriented style, and then we're gonna look at Pytest framework. There is a unit test framework and all that. Okay, so we're gonna look at those. So let me launch PyCharm first. Let me start sharing the PyCharm. All right, let me know, guys, if you can see the PyCharm window.
I can see.
Okay, perfect. Okay, so I'm gonna create a new file. So I'm gonna create a new Python file, and I'm gonna name this functional and object-oriented programming demo. Okay. Okay. So here I have this new file. So if I want to have a function, I would have a definition. So I would put something like a DEF. DEF means it's a definition. Okay. And let's say I want a simple function, adding of two numbers. Okay. So I can say A, comma B. Okay. And I'm going to say A plus B. Okay. So that is what I'm returning from there. Okay. I mean, this is just a demo here. So this function is going to add two numbers and it's going to return that number, return the combination or sum of those numbers. Okay. Now I can call this with different parameters. So I can say what is the sum, or yeah, let's say add. Okay, add 2 and 3. Okay, so I can say add 4 and something really large number. Okay, something like 10,000 and so on. So I can call it with different parameters and I can get the return value. Okay, so what's going to happen here is this number 2 is going to be assigned to A, and this number 3 is going to be assigned to B. Okay, that means inside the code, whatever you do, it is going to execute those operations, and then you're going to see keyword like return. Return means this is the value that's going to be returned from the function. Okay, so once that value is returned, the print is going to print the return value. Okay, so think of this whole thing, which is add 2 comma 3 in parentheses, is going to be replaced. I wouldn't say replaced, but this is the corresponding code that will be executed. Okay, return 2 plus 3, which is return 5. That means you're going to get 5, and it's going to print 5. Okay, so that is what's going to happen when I call the function add 2 comma 3. Okay, so I'm chaining multiple statements together. Okay, so another way to do that is x equal to add 2 comma 3, and I can say print x. Okay, this line number 5, line number 4 and 5 is the same as line number 7. Okay, it's just that I'm not using a temporary variable like x, and I'm directly calling the add function inside the print function. Okay, so this is completely fine. I can also do multiple things like print add 4 comma 100 or 4 comma 1 comma, let's say 20. Okay, so that means first it's going to execute the innermost, which is add 4 and 1. That means it's going to get back 5, and then it's going to add 5 and 20. So yeah, you can have the parameter. So it's going to evaluate the parameter first, and in order for it to evaluate, it has to call this function. So it's going to call that function, get the value, and so on. Okay, so this is something absolutely fine in most languages. Okay, I mean Java, C++, Python, any language, this is supported. Okay, all right. So here, this is a functional style. That means I'm going to have different functions. Okay, so I'm going to have def, let's say subtract. Okay, a comma b. Okay, so I'm going to return A minus B. Okay, so that is a function definition. Okay, now I can say, is it a prime number? Okay, so if I want to find out if a number is prime or not, so the definition of prime number is it's not divisible by anything other than itself and number one. Okay, so I can say if anything is divisible other than one and itself, then it's not a prime number. So that's what I'm going to do. For I in range, did I say A? Sorry, let me change it to N. Okay, so from 2 to N, if there is any number that divides this thing, so if I say if N mod I equal to 0, that means it is divisible by that number between 2 and N. Okay, so remember, a range function, this last thing is not included, it's excluded. Okay, so it's going to go from 2 to N minus 1. Okay, so if I say 5, it's going to go to 2, 3, 4. It's not going to execute 5 because 5 is excluded. Okay, so the range function, the end element is excluded, so it's going to go to N minus 1. Okay, and if I say that if the number is divisible by anything in between that, then I'm going to return false. Okay, that means it's not a prime number. Okay, and after the for loop, if it is still executing, that means it didn't find a number that is divisible. So I'm going to return true. Okay, so this would be the definition of prime is prime method. Okay, pretty much what we are doing is we are trying to find a number. If it divides this number, if it is, then I'm going to return false, saying that it's not a prime number. But if I can't find anything, I'm going to return true. That means that's a prime number. Okay, now I can call the same code multiple times with different parameters. Is prime 100 number, print is prime, let's say 7. Okay, and is prime 1, 2, 3. Okay, you can, yeah, you can have, let's say is prime 97. So you can call that function with various parameters. Okay, now this is the advantage of functional style. That means you're writing the code once, but you're executing it for different parameters. Okay, you don't have to repeat the same code again and again. Okay, so that is a functional style programming. Okay, now let's say I want this. Okay, so let's execute this first and see. Um, so this guy. Okay, all right, so first add 2 comma 3, you're going to see 5. These are all expected values. Okay? So the first one here, it prints 5. The next one, it's going to print 5 and all that. Okay, so is prime 97. 97 is a prime number. Okay, 123 is not a prime number. It returns false. It's divisible by 3. 7 is a prime. It returns true, and so on. Okay, let me send you this code first in the chat. Okay. All right, so that is a functional style programming, and it's good for in some use cases. Like if there is something that I want to put in one place and I want to call it for different parameters. So in those cases, this functional style is very helpful. Okay. Now let's look at another style, which is object-oriented programming. Okay. Why do we need object-oriented programming, and what is the advantage of that? Okay. Now let's take an example of, let's say, an employee class. Okay. So let's leave this here. Okay, before we go to employee class, let's say that I want to have an employee class, and inside the employee class, I want to have the employee date of birth. I want to have the employee name, social security number, and maybe other things like address, phone number, those kind of stuff, email address, and so on. Okay, so if I want to store all those things, I mean, that would be difficult, right? So let's say I have one employee. He has a name, not one employee, but in general, every employee has name, address, phone number, email address, SSN, date of birth, etc. Okay, you can have other things also. Okay, now how do I keep track of all these things? I can have a dictionary, so I can have something like Rich, or let's say Bob. Okay, I can have the name as Bob. Okay, the address is let's say 123 Sound Street, New York, NY, and all that. Okay, so there is some address. Okay, and then you have a phone number. Okay, so let's say you can create a dictionary. Okay, now let's say if I have another employee, I have to declare another employee. Okay, let's say Sam, um, Mark, and so on. So you're gonna have these kind of declarations and all that. Okay, now let's say I want to print this guy, and I have to do something like print uh, Bob of name. Okay, I mean this works. Okay, but what if I want to find the age of this person? Okay, so let's say Bob, date of birth. Let's put date of birth as January 1st, 1990. Okay, let's call that is born on January 1st, 1990. Okay, now how do I find the age of this person, Bob? Okay, that means I have to write some function. Okay, so I have to say something like def find age, which takes a date of birth. Okay, and then I have to return current time. Okay, so datetime.now minus date of birth. Okay, now here date of birth is a string value, so I cannot just subtract the string value. I have to convert that um, string to date time, and then I can subtract and all that. Okay, so let's do that first, and then we're gonna come back here. Parse time. Okay, str date time dot. What is that date time? strp time, parse time. Okay. So we have month, percentage M, percentage D, percentage Y. Okay, so let me try this first. And Python is pretty good with testing out the stuff. So I'm going to launch my Python terminal here. I have a Python console. So PyCharm opens up the Python console in the very end. So I can open that up. Okay. So let's say I have a date of birth value as 1/1/1990. Okay. I want to try whether my this thing works or not. Okay. So I'm going to try this out. Control C. Okay, so that does work. Okay, so if I do datetime dot now minus, okay, so it's datetime dot now. Okay, right. So it does give me the difference, which is a time delta. Okay, so now means it's a current system time, and I'm subtracting with the date time that was passed to me as a date of birth. So what I did is I took the date of birth, which is a string value 1-1-1990, and I converted that to a datetime object. Okay, so when I say str p time means parse. Okay, the string, parse this, convert to a time, and all that. Okay, so it's going to give me a date object. The date object has year 1990, month 1, day 1, and this 00 is hours, minutes, and other things. Okay, so we don't have that. So it's pretty much January 1st, 1990. And then I subtracted the current system time minus that. So the age of the person is 12,549 days, 63,000 seconds, and all this. Okay. Now I can convert that to years and all that. But let's say that this is the age of the person. Okay. I mean, I can divide by 365 and I can come up with the number of years, months, and all that. But for now, let's say that this is good enough for that, good enough for our use case. Okay. So this is the age of the person. And that is what we are returning from that method. Okay, find age. Now, if I want to find the age of Bob, so I would have to call this find age. Bob DOB. Okay. And if I execute this, oh, sorry. Okay. So if I execute that, it says datetime has no method now. Okay, so let's do this. So datetime is one of the, I would say, a lot of functionality there, but inside the datetime package, there is time delta, there is other things and so on. And one of the module is a datetime. Okay, so inside datetime, there is a datetime module, and we are importing that. And in that, there is a now function. Now means the current system time. And there is strp time, which is converting the string to date time and all that. Okay. All right. So it gives me the age of the person. This person, Bob, has 12,549 days and 17 hours, 46 minutes, 43 seconds, and so on. Okay. So that's the age of the person. Now, let's say I have another person, which is Rich. I can have the same properties. I mean, I can have different properties, but same in the sense like name, address, and those things. Okay, so let's say he's in LA, California. Okay, and the date of birth is, let's say, December 12th, 1990. Okay, now if I want to find the age of this person, I can just say find age, Rich, date of birth, and so on. Okay, so now if I execute this, okay, so it gives me the value. Okay, so it's 12,204 days. That's how old this person Rich is. Now, let's say in addition to age, I want to find out, let's say he's a senior guy, or let's say, I'm trying to find some example. Yeah, let's say that is he a manager or is he not a manager? Okay, so let's write a function calling is manager. Okay, so that takes the whole employee object. Okay, and let's say it looks at the database. Okay, and it says query database, and then it returns true or false. Okay, return true or false based on whether it's a manager or not. Okay. In addition to manager, let's say I also want to have a functionality which is it close to retirement? Okay. So it takes an employee object, it looks at the database, and it returns true or false. Okay. I'm just putting false here, but you can assume that an employee object, an employee can have different methods. Okay. You can have age, find the age, is he a manager, is he close to retirement. You also want to print this in a fancy style. Okay. So you can say print employee. You can take an employee object and you can print in a nice style, which is, let's say, you want to put some stars. Let's say name is this. Okay. And let's say you want to put a bunch of stars again, and then you want to put date of birth. Okay, so you can make it fancy and all that. Okay, now you can see that the number of functions are going to grow. Okay, so let's say you have 20 different methods. Okay, I mean, this is just a demo that you want to have find age, is he a manager, is he close to retirement, print method, and so on. Okay, so the functional style may not be suitable in some of the situations, in the sense you're going to have a lot of functions here. Okay, and let's say I have another one which is student. Okay, so let's say I have a student object, and So let's say we are developing a software for a university. Okay, the university has a bunch of employees. The university has a bunch of students. The university also has, let's say, parents, um, or maybe parking lot. So you might have the vehicles. You might have other things. Okay, billing systems and so on. Okay, so if you want to design something for a complex enterprise software, the functional style may not be suitable because let's say a student, the student can have a bunch of things like student name. Okay. Um, okay. Student also has a date of birth. Student can have an identifier, student ID. Okay. And student also has an address. And they might have the courses that they're taking. Okay. So it can be a list of courses and so on. Okay. So you can have a different attributes compared to an employee. Okay. So that would be a student object. And now I'm going to have methods for the student object. Okay. So is student registered? Maybe the student is not registered for this semester. Okay. Maybe he was registered in the previous semester. So you're going to take a student object and you're going to return true or false based on that. Okay. You might have something like has parking space. Okay. Um, okay. For that student. Okay. So you're going to return true or false there. And then let's say I also have something like has overdue uh, billing. Okay, so there is some billing that the student hasn't paid, and this function can tell you whether that student has this or not. Okay, so let's say you also have something else like has insurance. Okay, so does the student have an insurance or not? So you can see that the number of functions are going to blow up. Okay, so you have employee object, employee related functionality. Okay, and then you have functions that are related for a student. So you can see that pretty soon it will be difficult to find out which function is for which. Okay, has overdue billing. Okay, that means is this overdue billing for student or employee, or is this for parking space? um, yeah, I mean, this might get complicated. Has parking space. No, is this has parking space for student or employee or other things? Okay. Print, I mean, here we are naming it so that it makes it clear. We have a parameter called student, so it makes sense. Okay. But I can use the same function for an employee also. The employee can also have parking space or not, and so on. So I might say something like person. Okay. Um, so the thing is, I mean, you can see the functional style may not be suitable here. So we can group all these things which are student related together, and I can create an object which is called a class. Okay. So I can have an object-oriented programming, which is, let's create a new file. So I'm going to have something like a student class. The class here is a keyword. Okay. That means I'm going to have an object which is called student. And let's, for now, don't pay much attention to this syntax. Um, let's say self name, date of birth, ID, and other things. Okay. So I can say self.name equal to name. Now let's just say um, student name, student date of birth. Yeah, if you guys have any questions, please unmute yourself and you can ask the question. No worries. All right, so here, let's start with a few things and then we're going to come back and talk about this. So here what we are doing is we are declaring an object called student object. Okay. Now this init, think of this init as an initialization. Okay. Initialization means that this is the first method that will be called I mean, most languages call this a constructor. Java, C++, I mean, everything is called constructor. Even Python also is called constructor. And in most of the languages, this constructor will be the same name. Okay, so if you look at Java, the constructor will also be called student. Same thing with C++ and all that. Okay, but in Python, it's called underscore underscore init underscore underscore. Okay, so anything you see underscore underscore in the beginning and in the end, that means they have a special meaning. Okay, so these are called dunder methods. So dunder means underscore in the beginning and underscore in the end. Okay, so these are, they have some special significance. And in this case, this is the initialization method. That means this is the first method that will be called. Okay, and it has date of birth, ID, and all those things. Okay, now let's say I want to find an age of a student. Okay, so I can say get age. Oh, by the way, self, what does self mean? Self means it's an instance level variable. Okay, that means it refers to itself. Okay, so if I say self.name, that means that name is associated to the student. Okay, if I say self.date of birth, that means this DOB object is associated to this student object. Okay, if I don't put a self, that becomes a local variable. I mean, that after this function is executed, this variable will be no longer valid. Okay, so you have to do self dot to make this variable stick across the different methods. Okay, so let's say get age. Okay, so we're going to use the previous code that we had, which is find age. Correct. Okay, so here you can see that the self.dob, I didn't assign the dob in this function. Okay, so I got the dob from here. Okay, what it means is the get age method has access to the self, and anything that's in the self is accessible in this function. Okay, um, so think of self as itself. Okay, so anything that you assign to the self, you can access it later in the methods and so on. Okay, so let's take an example here. So I can say I have a student called Bob. Okay, and I'm assigning the name as Bob Marley. Okay, and let's say date of birth is, we'll go with 1/1/1990, and student ID is 1234, or let's say 2001. Okay, so that's a student ID. I can have another student, Rich equal to, before we go for another student, if I want to find the age of this person, I can just do bob.getAge. Okay, and that's it. I don't have to pass any parameters. I don't have to keep track of that student or anything. Okay, so once I assign the variables, I can say get age, EC, does he have parking space and all that. Okay, so this makes it clear uh, because Bob is a student. I mean, the code itself is very self-explanatory. Okay, Bob is a student, and then I'm saying bob.getAge. What is the age of Bob? Okay, here I'm assigning the date of birth. Okay, so which is this guy. Okay, second parameter. So here what's happening is when I call this line number 13, this is going to call this initialization method, which is a constructor, and the constructor is going to set all these different member data. It's going to set the name, age, name, date of birth, and identifier. And then when I call the get age, it's going to do this computation, and it's going to get the self.date of birth. Okay, self.date of birth is assigned here, and we're going to get the value and all that. Okay, so let's get another student. Okay, so here we'll just say Richard Kinley. Okay, and we'll go with December 1st, 1980. Okay, and his student ID is 2002. And I can say what is the age of which. Yeah. Yeah. So now if I run this program, sorry, let me run this program. Okay. So you can see that the first statement that is printed is for Bob. That's the age of that person. And the second statement is printed for Rich. Okay. So the code is going to be a little cleaner because anything that's inside this object belongs to the student. Okay. Let's say if I have another class, which is employee. Okay. And then I can have employee related methods. Okay. So I have a constructor which sets up the name, date of birth, and okay, let's call it here courses and other things. Okay. So you have a constructor here. You're setting up the name. Yeah. Now here I can say what are the methods we had for employee. Yeah, is close to retirement. Okay, so let's add that here. Okay. And I don't need to get the object, so I can just do self. Okay. And yeah, so the thing, as you can see here, all these methods are inside the employee class. So it makes it cleaner in the sense anything that's inside the employee class belongs to that particular object. Okay. So these methods are employee methods. And these methods here are student methods. Okay. So I can have other objects as parking space. Okay. Yeah, you can go to database, query DB, and return true or false. And in this case, I'm just going to say return true. Okay. And so on. So all these methods are belonging to the student class. Okay. Yeah. So the whole point of object-oriented programming, and this is an object. Okay. The same style as functions here, but we're going to put the function inside the object so that it makes it clear and cleaner because I don't have to pass these variables like date of birth to the function, and the function is not gonna, I mean, you can pass those values, but let's say this has to get 10 different parameters. Okay, so I don't have to pass 10 different parameters. Everything is inside the object, inside the self itself, and I can use those self variables and I can get the values and so on. Okay. But yeah, I mean, this helps because everything is grouped inside the object and it's going to be cleaner. Either reading the code is cleaner, maintaining the code is going to be much better because you know which function belongs to which, and the number of parameters are going to be less. So the state is going to be maintained in a nice way. Okay. So that's object-oriented programming. I'm going to talk about like base class, derived classes. But for now, do you guys have any questions so far? Hello.
Hey, Vasi, yeah.
Were you guys able to hear so far?
Yeah, I was able to hear.
Okay, all right.
Uh,
All right, guys, let me know if you guys have any questions. If not, then I'll go to the other topics.
no questions from me.
All right. So now you can see that there's a get age method. This get age method is common for an employee. So employee also going to have a get age method here, okay, which is the same code base. So it doesn't make sense to repeat the same code multiple times. Okay, so let's put this code a little below.
Recording in progress.
Did somebody start recording or something? Okay.
I only see the prompt of you recording.
Right. I don't know. The audio just came that recording.
Even I heard it, yeah.
All right. So here you can see the get age method. The get age method is going to be for student. It's going to be for employee. It's the same implementation. Okay. So let's do this. Right. So in those cases, what object-oriented programming says is you don't have to repeat the same code multiple times. You can have something like a common base class. Okay. And you can put whatever you want in the common base class. Okay. So I'm going to have something like get age. Okay. Let's do this first. Okay. Let's have a constructor. Okay. And you can see that whether he's a student or an employee, they're going to have an identifier, they're going to have a date of birth, they're going to have a name and all that. Okay. So I can put the common repetitive part in a common base class. Okay. So I can have this thing self dot person name. Okay. Equal to name. Self dot date of birth equal to date of birth. Okay, so now I have that, and then I'm going to have this method called get age. Okay. All right. So here there's a person class, and every person is going to have a name, date of birth, identifier, and all that. Okay. So the student is actually a person. Okay. So we're going to put parentheses, and inside the parentheses, we're going to say person. Okay. So this is the style of Python, which says that the student class is derived from the base class, which is person. Okay. So person is the base class, and then you have a student class. Okay. So if I have to show you as a picture, let me share. Yeah. Hopefully you guys can see the browser.
Yes.
Okay. So, right. Think of this way, right? Okay. You have a base class, and everything that's in the base class, the derived class is going to get it. Okay. What it means by getting it, that means anything that is defined here is going to be part of the student. Okay, so let me try to find a good picture. Or subclass. Yeah, let's look at this guy. Okay. Mm, okay, so this is the same example that we are looking at. Um, yeah, so this is a good diagram. Okay. Okay. So when it says parent class, think of this as a base class. Okay. Child class means the derived class and so on. Okay. So the base class is going to be a subset of the derived class. Okay, so that means everything that's in the person class, the student is going to get it. Okay, so think of this inside circle as a person class, and this outside circle as student class. Okay, so everything that's in the person, the student is going to get it. Okay, so think of this person as inside the student object. Okay, so let's say there's another object called a special student. Maybe he's physically handicapped uh, and all that. Okay, so in that case, you're going to have another level, which is student, and you're going to have additional methods like um, maybe special insurance programs or whatever. Okay, so there are some additional properties. Um, So there's a special student class. Okay, so if you go back to this diagram, so the innermost circle is going to be person class, and this middle circle is going to be student class. The outer circle is going to be special student. Okay, so you have three classes, and everything that's in the person class, the student is going to get it. Everything that's in the student, the special student is going to get it. Okay, but there's going to be additional methods. Okay, the student object can have, so we have a person class which has get age. Okay, that means this person parent class has get age, and the student can have additional methods. In this case, you have has parking space. Okay, so this new method, some new method, is our method which is has parking space. Okay, and then the grandchild class, which is the special student, is going to have additional methods and so on. Okay, so every object can have its own methods, but it's going to get everything that's defined in the base class. Okay, so the person, anything that's inside the person, the student is going to get it. Anything that's inside the student, the special student is going to get it. Okay. Um, so this is the derived class structure. You have a base class, derived class, and all that. Okay. Now the employee class employee is also a person. Okay, so yeah, I'm going to put in the parentheses person. Yeah. Okay. Um, so here, one thing to remember in Python is that unlike additional languages or unlike other languages like Java or C++, they automatically call the base class constructor. But in Python, you have to explicitly call the base class constructor. Okay, so I have to do something like this: super person init name date of birth. Okay. So here, what's happening is I'm setting up a bunch of things, and then I'm calling the base class constructor. Okay. Um, so let's put the employee class aside for now. We'll come back to that. Okay. So here you can see that we'll also get rid of this special student. Okay. Yeah, so here we have a student called Bob, and we are setting the attributes, and we are just saying bob.getAge. Okay, so the getAge method is not part of the student. It's actually part of the person class. Okay, the person has it, getAge, but I'm able to call that getAge on the student because everything that's inside the person, the student is going to get it. Okay, because it's a base class. Okay, so student is a derived class and this is a base class. So everything that's inside this person object, the student object is going to get. So I'm able to call the get age. So when I call the get age, it's actually calling the person dot get age. Okay, so it's going to call person dot get age. And inside the get age, it's going to get the date of birth, do the subtraction, and return the value. Okay, so let's try this out. Okay, so courses is missing. Let me remove the courses. Super takes at most 2 arguments, 3 given. Let me look up the syntax for the super. It's a little confusing. or you just do super. This is not a good style because if you have multiple base classes, which base class is it going to call? Okay, so let's not use that style. I don't like this style. So let's look at other things. So we are. Okay, hey, Mani, I think you're unmuted. Okay, so this is better actually. So you use the class name dot init. Okay, so let's directly call it instead of super. Okay, we can just do person dot init. Okay, so that means we are calling the base class constructor. Required positional argument ID. Oh, you just pass self. Okay, the first parameter has to be self. Yeah. Okay, there you go. Okay, so you can see that what we are doing is we are calling the base class constructor, and see this constructor is accepting 4 parameters, so I have to pass 4 parameters, and the first one is a self, that means itself and all that, and then I'm passing name, date of birth, ID, and all that. So here we call the base class constructor, but when I call the get age of the student, it's going to call the base class constructor of this person class, and it's going to print that and so on. Okay. All right. So now the same thing I can do for an employee class, the person, I can do person dot init. ID and all that. Okay. So I can declare an employee and I can say, what is the employee's age? Okay. So I can say E equal to new employee. Let's call her Mary. Okay. Date of birth is, let's say June 1st, June 10th, 1992. Okay. And ID is 1234. So that's ID. So I can do e dot get age. Okay. So even though, sorry, this age should not be here. Yeah. So even though the employee class does not have a get age method, this is still going to work fine because it's coming from the base class. Okay. It should print 3 times, right? Because this is student rich and this thing. Okay. So let's do this. Oh, interesting. It's only printing 2 times. Mm. Oh, sorry, I'm not doing a print here. Okay, I'm supposed to do print. Okay, print e dot get age. Okay, so you can see that it prints the employee age also. Okay, so that is how the base class derived class objects are going to work. Anytime you see this, something like inside the parenthesis, that means that's a base class, and anything that is, yeah, anything that's in this guy is you're going to get it automatically. Okay. All right. Any questions so far? Okay, now with this understanding, now you guys know the functional style, how to call functions, and you guys know about object-oriented programming. Now let's look at some testing, okay? So let's create a new file.
바트를 기울듯이 살아내가 되니까 지금
Oh, yes. Okay. So there's I created a test file, test underscore demo.py. Okay. So here, let's go with the add function, add a comma b. Okay. Which is a previous function that we were looking at. Okay. Return ab. Okay. Now, if I want to test whether this function is working fine or not. Okay. So let's say we don't know how it is implemented. Okay. So let's say this is in a different file. Okay. So let's take it off from here. So let's say it's inside this file. Okay. So if I go back here, there's the add method here, right? Add, subtract, is prime, and all this. Okay. Now, how do I test whether this, let's say the developers did this code and you are trying to test whether they have done a good job or not. Okay. So I'm going to do this from import add. Okay. So I can do something like print add 2,3. Give me one second. One problem with Python is it won't be able to import the local files. So I have to change the path variable. So let me change the path variable first. By the way, let me send you the code for all this. It says this is too long, so I'm going to send you this new code. Okay. And I'm going to send you this code also. Sorry, object-oriented code. Yeah. Okay. All right. So I sent you both object-oriented code and the functional code. The second message that I sent is object-oriented programming code. All right. So here, if I want to import the local files, I think I have to do something like this. Okay. From import add print. Let's try to run this code. If it works, I'll tell you what I'm doing here. Okay. All right. Yeah, let me comment this thing on. Can someone tell me how do I comment multiple lines in Python? Yeah, that's right. Triple quotes. Okay. I'm gonna comment this code also. Okay, so let me save it. All right, so you can see that I'm executing this piece, which is test underscore demo. And what I did is I imported the add function that was defined in the other file. So it's inside this file, which is functional. Let me share just this guy, PyCharm here. Okay. All right, so you can see that I have this add method inside this file, which is functional oop demo.py. Okay, so that's where this function is defined. and I have a test file. Now we want to test this function, whether it's working fine or not. Okay, so how do I test it? First, I want to get access to that function. Okay, so I'm importing that function, add function, from that file. Okay, so I'm saying from this file, import this guy. Now you can see that I did import sys.path.append. So the reason why I did that is / means it's a current directory. Okay, so I'm saying any import that you're gonna see, look in the current directory. Okay, / means current directory. So I'm saying any following imports or anything, look in the current directory. So it's gonna look for this file called functional object-oriented programming demo.py in the current directory, and it will be able to find. And from that file, it's gonna get the add function. Okay, and we are saying print add 2, 3. That means it's going to call that function and so on. And here you can see it prints 5. Okay, 5 means it executed the code and it got that. Okay, so I can also get isPrime method. Okay, so I can do the same thing, which is print isPrime 97. Okay, so now if I call this should work fine. Okay, because it prints true, because it's able to get the isPrime method from the other file and so on. Okay, so this is how most of the times you're going to see the code. That means you're going to see a lot of imports, and you're going to see the function defined or called and so on. Okay, so the function definition is in a different file, but you are calling that and verifying and so on. Okay, now let's take the isPrime method and let's try to test whether it's working fine or not. Okay, so how do I know this isPrime method is working or fine or not? Okay. So a couple of ways. So I can say if isPrime 97 equal to true, that means it is a prime number. I'm getting back expected value. So in that case, I'm going to say something like works fine. Okay. Else I'm going to say print doesn't work. Okay. Now if I run this, so it prints something like works fine. Okay. Now what if I want to have another scenario? Like this is a prime number. It works fine for prime numbers. Okay. What about a non-prime number? Okay, so I'm going to say 4 equal to false. Okay. Print works fine, else doesn't work. Okay. Okay, so it works fine, and so on. Okay, so it's pretty good that it's working fine. But what if I have a bug in the code that it doesn't work all the time? Okay, so I'm going to say something like return false here. But if n mod 2 equal to 0, return true. Okay, so let's say there is a bug in that, and for even numbers, it's going to return it's a prime number. Okay, so now I tested for 4. I run this code. If isPrime 4 equal to false, let me do this. Okay, so so for if let's say that we don't have access to the add function, or maybe add function is so complex, sorry, isPrime method is so complex that it is beyond our understanding. Okay, so it is going to the database, getting some values. It is doing some calculations. Maybe it's going to another database, getting some values, doing more calculations, and so on. Okay. In this case, there is no way for us to go back to prime method and try to understand what it's doing. Okay, so we are just calling the prime method isPrime, and we are trying to find out whether it is working fine or not. And in this case, yeah, this should be false. IsPrime 4 equal to false, but I got true. That means it's not working. Okay, so this is what you're gonna see doesn't work. Now the thing is, with this, let's say there are hundreds of different test cases. You're going to see works fine, doesn't work, works fine, doesn't work, and all that. Now, which test case is working, which doesn't work, I have no idea. Okay, so let's say I have a negative number, or maybe another test case here, which is 5. Okay, I have something else. Well, okay. So you're going to see works fine, doesn't work, doesn't work, doesn't work. Okay, so which one is working fine, which one doesn't work fine? Let's say if you have hundreds of these lines, it's difficult to see where it have failed and all that. Okay. Now I can also print something. It works fine for 12, doesn't work fine, doesn't work for 12, and all that. Okay, but this is very, I would say, not a feasible way to test it, because you have to write the same repetitive code and so on. I mean, there are ways to make it simpler also. I mean, I can put a loop, I can loop through the variables, and I can say is prime or not and all that. Okay, but the easiest way is doing something like testing, which using test frameworks. Okay, so for now we'll use a unit test framework, or maybe we'll use Pytest. Okay, import Pytest. Hopefully you guys have installed Pytest. If not, then go to, yeah, if you guys haven't installed Pytest, go to File, Settings, and in the project interpreter, search for project interpreter. Okay, and when you select the project interpreter, you're going to see a plus sign here. Okay, click on the plus sign and search for Pytest, and you're going to see Pytest here. Okay, in my case it's already installed, but if you haven't installed, you can click on this install package button here, and that should be able to install.
ఇది ఆటోమేషన్ టెస్టింగ్ అంట. టెస్టింగ్ లో ఎలా ఉన్నాయి?
Hey Prashna, you are unmuted. Okay, so yeah, if you haven't installed Pytest, so go to project interpreter and install Pytest framework. Okay. So again, one more time, file, settings, search for interpreter, and click on the plus sign, look for Pytest, and install the package. All right, guys. So I'm assuming that every one of you have installed this particular package, Pytest. Okay. So let's say we import the Pytest module. So this makes it much easier. So I can just do something like this. Okay. Def test is prime. So I'm going to write a method called is prime. Okay. And I'm going to do something like pytest.parameterize. Okay. Mark.parameterize. And here I want to parameterize for different test cases. Okay, so here I want to have something like what is the input and what is the expected result. Okay, so when I have an input of 97, I'm expecting the output expected result as true. Okay, and if I have number 4, the expected return is false. Okay, and if I have 5, this should be true because it's a prime number and so on. Okay, so I do that and I say input comma expected result, and then I'm going to say assert is prime of input equal to expected result. Okay, so this whole code that we saw before, which was multiple lines, is replaced by these 3 lines, okay, or 4 lines. Okay, so here what I'm doing is this use the Pytest framework, and this is the input value, which is the first value. Okay, so let me format it nicely. Okay, so this is the input value, and this is the expected result. Okay, for 97, I'm expecting it to be true. For 4, I'm expecting it to be false. For 5, it is true, and so on. You can add more scenarios, more parameters, and all that. Okay, and this is a syntax of Pytest. So think of this way as whatever you specify input there, it has to be specified here. Sorry, here. And whatever you specify here, expected result, you have to put it here and so on. Okay, so these are the parameters to the function. And inside the function, I'm calling assert. Assert means make sure that is prime, when I call with this input, I should get expected result. When you say equals to, that means it has to match. Okay, these two has to match. And the assert, we are verifying that. Okay, so let's run this code. I'm sorry, I'm not running the Pytest code. Let's do pytest.main. Okay, this is good now. Okay, so previously we got some code which says doesn't work. Okay, here you can see that this is syntax of Pytest, which is .f dot. Okay, dot means succeeded, f means failed. Okay, so it ran 3 test cases. You can see collected 3 items. That means there are 3 test cases that it ran, which matches with what we have given, the 3 test cases. And dot means it succeeded, f means it failed. Okay, so the second test case failed. Okay, and what is the second test case? It's telling me that this is the input 4 and the expected result is false. Okay, so you're expecting it to be false, but what I got is this thing. Okay, so you can see is prime. Let me scroll down. Okay, see, this is the code that you're executing, which is prime input equal to expected result. And in this case, for the input is 4 and your expected result is false. So, but we got back is prime for 4 as true. Okay, so it says true, you got this, but this condition is incorrect. Okay, so it's telling me exactly what is it that is not matching. Okay, so in the previous case, we had to print something like doesn't work, and then I have to say something like works for 5, doesn't work for 5, and all that. So I have to provide those things. But what Pytest is doing is that it took all this code base and combined into like 3 or 4 lines. Okay, and then whenever it fails, it's going to give me like elaborate message saying that, hey, this is not working for this parameter. This is what I got. You are expecting this, and so on. Okay, so it makes it very clear, and it also kind of displays some nice things like how many succeeded, how many failed, kind of stuff. Okay. There are other things that can help me with Pytest. I'm going to talk about those things also. But any questions so far? Yeah, okay, fine. So here, let's fix that code. Let's say you complain to the developer that, hey, your prime method is not working for number 4. Can you please fix it? So he's going to go there and he's going to test that and he's going to fix it. Okay. Now, if I go back here and if I execute, okay. Yeah, so you can see that it says collected 3 items and you're not going to see any F. F means failure. But you don't see any F, like 3 dots means succeeded and so on. Okay. And at the bottom also, it shows up something nicely, 3 passed. So we executed 3 test cases, 3 of them, 3 passed and everything. Okay. There's one warning. Let's see what is the warning here. Okay, something like Pytest. Okay, so internal error, fine. Let's ignore that for now. But you can see that we running 3 test cases and 3 of them succeeded. Okay, sorry. Let's add a couple of more test cases. Okay. All right, so here is a prime number. And we got these scenarios here. For a real prime number, I'm getting back expected value. Okay. For an even number, it should be false. For a real prime number, I'm getting back true, and so on. Can you guys suggest some test cases that I can add here? Yeah, Mani, Teja.
Yeah,
Yeah, Mani, can you suggest some test cases that I can do here for is prime? Yeah. Um,
7.
7. Okay, 7 is a prime number. I think 5 is very similar, okay, which we already covered there, but that's fine. Okay, we're gonna test more prime numbers. 7, true. Okay,
13.
yeah, but it's the same. I mean,
19.
scenario is the same, right? I mean, in the
Yeah,
sense,
it's same as 5 and 7.
yeah, exactly. So I want you to come up with a different scenario. I mean, we tested for even numbers, we tested for prime numbers, we
Okay.
tested for this is also prime number, this is also prime number.
Number. Even number. Even number. Non-prime numbers.
1. Sorry, did you say? Okay, let's say 9. 9 is an odd number. Okay, 9 is 9 a prime or non-prime?
It should not be prime.
Exactly. So it's a false. Okay. So we tested for even number. Okay. We tested for odd number, which is non-prime. We tested for odd, which is a prime. What other test cases can I add?
77.
Yeah,
Is
that's
it-
still a prime number. I want a different scenario. Okay. So we didn't test for 0. Okay. So is 0 a prime or non-prime? Right? That's a question that even I don't know. So let's expect it to be false. Okay, I don't expect 0 to be false. How about 1? Is 1 a prime number or not a prime? I think that should not be a prime, but let me.
No, like both 0 and 1 should not be prime.
Okay, good. All right, so let's look at those things. How about for negative numbers? Okay, so
Yeah.
is negative numbers prime, non-prime? -9. It should be false because -9 is divisible by 3. That should be false. Now, does our function work as expected? I don't know. So let's see. Okay. How about for strings? If I pass a string ABC, what happens? Okay. That should be false. Okay. How about for a really large number? Okay. So if I give a really large number, does it work? Let me put a 2 at the end. That's an even number. That should be false. Okay.
Float numbers.
Yeah, float
0.
numbers. Yeah, right, correct. So let's put 0.5 and that should be what false, right? So let's do something like 20.5. Okay. Good. Yeah. So that's this is a different scenarios. Okay. So that we are supposed to test. And you can see that it makes it much easier, right? So you just keep adding the parameters. What is the input? What is the expected value? The code is going to remain the same. Okay. And we are parameterizing these different test cases. Okay, so now if I run this, a couple of them are going to fail. Okay, yeah. So you can see that 5 failed, 7 passed. Okay, so out of the 12 test cases that we have provided, 5 of the test cases have failed. Okay, which ones failed? Is prime 0 false. For 0, it got back true. Okay, for 1, it got back true. For -9, we are expecting false. We got back true. Okay, for a string object, it actually threw an error, which is expected. Okay, but strings are not supposed to be passed. We passed a string that threw an error. Okay, for a float object, it also returned an error, which is incorrect. Okay, because it's a number, probably it should have returned false and all that. Okay, so now you can go to the developer and say, hey, for these scenarios, it's failing. I want you to fix it. Okay, so you have to create a Jira ticket to him, let him fix, and so on. Okay. So this is something that you would be automating. I mean, once you write this test case, you can put this in the Jenkins. Okay, so in the previous session, we saw Jenkins. Jenkins pretty much will run whatever you tell it to run, and you can schedule it. Hey, you run this every day. Okay, so let's say isPrime method is working today, but tomorrow somebody changed it. It's going to break tomorrow. Okay, but you're going to run Jenkins every day, so it's going to catch it right away. Okay, so somebody changed the code base. And when the Jenkins jobs run, it's going to fail the jobs. You're going to see the fail job. It's going to say, hey, it's failing for these things. And then you're going to catch the issue right away. Okay. So now let's go back to the code base and let's try to fix it. Okay. So if n equal to 0 or n equal to 1, return false. Okay. So for 0 and 1, false. For negative numbers also. Okay. So I'm going to do n less than equal to 1. Okay, for negative numbers also. Oh, no, actually negative numbers, not really. Okay, equal to 0 or n So, okay, for 0 or 1, this thing, okay. But if n is less than 0, that means it's a negative number. I'm going to keep track of this, okay. N equal to -1 time n, okay. I'm going to change it to positive because -9 or +9, it doesn't matter. Is it a prime number or not, okay. So these are the steps the developer will take. He's going to fix those, fix the code base. And when the next time you run that, out of the 5 failed, now only 2 are failing, okay. The other one succeeded, okay. Now the type error string. So you're not supposed to call for string. You're getting this error, which is acceptable, okay. This type error, okay. What is this? A float object, yeah. Okay, what about float? Okay, so here in the range method, so we are passing a float object. So you can go to the developer and say, hey, I'm passing a decimal number. Instead of returning me false, you're returning this error. So maybe he's going to do something like n equal to int of n, convert that to integer. Let's do this actually. Yeah, so let me remove the string because the string method is going to yeah, throw an error, obviously. So I'm going to return that. Okay, so you can see that total 11 items, 11 test cases, 11 out of the 11 are passed. Okay, so it shows that 11 passed. Now we don't have to worry about like, do I need to print statement here? So in the previous code base, you saw that we had this if else and all those kind of scenarios, right? Now we don't need to do that. If anything fails, it's going to tell me what is the parameter, what is the expected value, and all that. Okay. This is one advantage of Pytest in the sense if you have hundreds of test cases, it's going to run all those test cases and it's going to show me. So here, what's happening is it's running one test case at a time. Okay. So it's running the first test case, the next test case, and so on. Okay. So in, and this is pretty fast because is prime method is pretty fast. So the whole test case takes less than a second. So I think it should display how long it took. Okay. So it doesn't display how long it took, but yeah. But you can also configure Pytest to run parallel. Parallel means instead of running one test case at a time, I can say, hey, run multiple at the same time. Okay. So I can go to run configurations. Okay. Test demo. So there's a Pytest command and allow parallel run. Yeah, let's run with this project interpreter. Script parameters. Okay, so we're gonna run the Pytest. Okay, so here is a module name. So instead of a script path, I'm gonna select module name and I'm gonna select Pytest module. Okay, so Pytest module. That was a Pytest demo. The parameters are gonna be test_demo.py. And I think -j option or -m option. Okay, I think -j. If I say 4, okay, that means Pytest is going to run 4 test cases simultaneously. Okay, so you can see that you have multiple parameters here. So we have 11 test cases. Out of the 11, it's going to run 4 at a time. Okay. Now imagine this: if you don't have a Pytest framework, how would you run them in parallel? So you have to write some code base. You have to create some threads so that they run in parallel and all that. Okay. So this is one advantage of Pytest that you can decide how many to run in parallel. It can also display. Give me 1 second, guys. Somebody's knocking on my door. All right, so yeah, so you can run in parallel by specifying with the -j option. Okay, so let me just confirm if it's -j or not. Give me 1 second. Okay, so let me share the browser. Okay, so Pytest. How to run Pytest tests in parallel. Okay, so there's a -j option or some option that can help you. Okay, so no, not this. Let's do another one. Yeah, -n. Okay, -n option is gonna run those many number of test cases in parallel. Okay, sorry, it's not -j, but it's -n. Okay, so when I run this, that means it's gonna run 4 test cases in parallel. Okay, so let's run this and see. Okay, hopefully it will be able to find test demo, and test demo will be able to find this path. Okay, so let's try this and see. Okay, it's running Python x -n Pytest. Okay. Yeah, let me remove this Pytest main. It's unable to recognize a -n option. Okay, so first let me remove this -n option. Let me even see if this is able to locate the Pytest module. Okay, so okay, so it's able to locate the Pytest module, which is good. Actually, not. Let me comment this Pytest.main. Okay, this is even better. Okay, all right. So let's edit the configurations one more time. Options. Yeah. Let me just go back here. Like we need this Pytest xdist plugin. So let's install this xdist plugin and let's try this one more time. Okay, so settings, interpreter. Okay. I'm going to send you the code so you guys can run it in parallel also. Hmm. Let's try to see why this is throwing an error. So it seems to be like it's complaining that pip is not the right version. No such option build directory. Okay. Yeah, 1 second. Let me update the pip command from a command line. Okay. In the meanwhile, let me send you this code in chat. Yes, I'm running pip 24.0. Okay. Pip can update itself. So okay. Pip install update pip. Okay, so let's run this command. So pip is primarily Python package manager. Okay. So it is already up to date. And so is a I have a little older version of Python, which is 3.8. Are you guys getting the same error when you do file install and install Pytest xdist? Yeah, for me, it throws up an error saying try to run this command from the system terminal. Make sure that you use the correct version of pip installed. So something to do with the version number or version mismatch. So let me run from here. Okay, pip install Pytest. Okay, let me do pip install Pytest xdist. Okay, so it seems to be working fine from command line.
I was able to install xdist, but my ID is, I think, slightly different. Community edition 2023. So
Okay.
either something with environment variables set up at your end or ID itself.
Okay. Okay. So I ran it from the command line. So let's see if it, okay, seems to be working fine. But yeah, if you install that package that I mentioned in the chat, it should work fine. So you can see that it says 4 workers. Okay. That means I specified minus N4. That means it's going to run 4 test cases. 4 test cases simultaneously. Okay. So let's say if you have hundreds of these different scenarios, then it's going to run 4 at a time. Okay. Or you can even change that to 6, 8, depending on how powerful your CPU is. Okay. Let's have other function, which is test add. Okay. So now I want to test this add method. Okay. Now the add method has 2 parameters. Okay. Which is A and B. And yeah, so I'm going to say input 1, input 2, and expected result. Okay. Or expected sum. So I can do different scenarios. 1, 2, I'm not supposed to get 3. Okay. Let's have a complex numbers, maybe like a big numbers. Okay. Oh, I need to use a calculator for this. Okay. So you can see the scenario. That means if I have multiple test cases, okay, so you have one for testing the prime numbers, and you have one for testing the addition function. You have one to test the subtract function. And for each of the test case, you have multiple scenarios. So overall, your project might have like 300 test cases, 500 test cases, and so on. Okay. So if you run one test case at a time, that's going to take 2 hours or 3 hours for you to just find out whether the software is working fine or not. Okay. But if you use Pytest, you can specify minus n. Minus n means you are specifying how many tests should be run in parallel. So instead of running for 2 hours, it's going to finish off in 20 minutes or 15 minutes and so on. Okay? Because now you're running 4 things at a time. Okay. So let's just quickly do this. Input 1, input 2, expected sum. Yeah. Okay, so let's remove. Okay, so we can also test for negative numbers, right? So I can have a negative number, -5, -5 should be -10. Okay, and let me put this correct value. Okay, so it's gonna be 53. Right, okay. Okay, so we got negative numbers, this thing. So if I combine 0 and 0, that should be 0. That's one of the test case. How about decimal numbers? 0.5, 0.5 should be 1. Can you guys come up with some test case scenarios here? Yeah, as a automation testing, I mean, one of the things you have to do is come up with the different ways to see if the functionality can be broken. Yeah, your job is to basically find out bugs and errors and all that. Okay. How about I pass on some fractions? 1 divided by 3. 2 divided by 3, I should get back a 1, okay? Which is the same, okay? 1 divided by 3 is evaluated into 0.3333, and this thing is that, okay? Yes, fine. We can test for strings or other additional methods, but for now, we'll ignore this, okay? So now if I run this, the total number of test cases will be 11 in the previous case, and then we have 5 test cases here. Total 16 test cases. Okay, so if I run this, it should tell me there are 16 test cases. 17 actually. Yeah, right. So 11 there and 6 here. So total 17 test cases. Okay. So and it says that 17 have them passed. Okay. And it is using 4 workers. Okay. If it is single worker, it's going to take a little longer. But for now, in our case, it's pretty straightforward. Add prime is pretty fast. So it doesn't make much difference. But let's say in the real world, it may be going to database, getting some values and all that. You don't want to run one test case at a time. Okay, so Pytest will help you run multiple things at the same time. So you can see the benefits of Pytest. You can parameterize, you can run multiple things at the same time. There are also additional things. Okay, so let's say you want to run this test case every day, or you want to, this is a fast test case. Okay, so this add method is a fast test case, and this is a slow test case. Okay, or maybe this is owned by group. Let's say there are multiple groups, developer groups, and this is owned by team A, and the second test case is owned by team B. Okay, so in the Jenkins, you want to run only team A's test cases. Okay, and you don't want to run team B's test cases and so on. Okay, so you can also group the test cases. Okay, so Pytest has a group functionality. Okay, so let me just there's something called mark. Okay, mark means you can specify this is a marker, and you can run only those markers that you can specify. So let's see. So these are some additional things. Skip. Okay, so let's say your test case is not ready yet. So I can do something like pytest dot skip. Okay. Now that means it's going to skip this test case. It's going to run these test cases. Okay, so if I run this 11 should not be run, but only these 6 test cases should be run there. Okay? Why am I getting error? I think the skip has to be inside, not outside. I'm not sure. Let's try this out. First, let me remove the configurations. Yeah, 1 second. Pytest.mark.skip. Okay, sorry. Yeah, so it's pytest.mark.skip. And that should be able to skip that test case, but it should be able to run the other 6 test cases. Okay. Yeah. So you can see instead previously it was showing the ... but now it says S. S means it's skipped. Okay. And when the test case failed, you saw F. F means it failed. Okay. And it would give, whenever it fails, it would give elaborate message like what is the expected, what is the real value, actual value, which line failed, what is the assert, and all those kind of stuff. Okay. But what if you want to skip based on a condition? Okay. Skip if the config file has something like, not config file, let's say that, let's say there is an environment variable or like a global variable. Okay. Let's say product is ready equal to false. Okay. Product is not ready yet. Okay. So let's say there's some variable that says that, and you can say skip if product is ready equal to false. Okay. So if the product is not ready, then you want to skip it. Okay. But if the product is ready, then you don't want to skip it. So based on some condition, you are skipping it or running it and all that. Okay. I mean, I put this as a global local variable, but this variable can be running, you can be getting that from somewhere else. Okay. Maybe from a different file or maybe from the environment variables and all that. Okay. So if the product is ready, it's not going to skip it. It's going to run the test case. Okay. So that's one marker. So yeah, I said the team A, team B, and you can run only those test cases that you want. So let me run those, show you the marker there. Yeah, in the skip also, you can specify some text, why you want to skip that so that it's helpful for the other team members, like why are we skipping this test case and so on, okay? Let me just go. Okay, so let's use this Slack overflow. It'll be very specific, okay? Yeah, something like this. So you can say mark as, in this case, is specified as test 001. In our case, we can do something like this, okay? Let's see that key. There should be an easy way to do this. Okay, pytest.mark dot directly. Okay. Okay, so let's say we have two teams, team A, team B, and I want to run only the team A test cases. Okay. or let's say we want to run only for team B test cases. Okay, so I can go to my configurations and I can specify -m team underscore A or team underscore B. Okay, that means it's going to run only those test cases that have a marker as team B test cases. Okay. So it should skip this thing. Okay, so you can see that it says 6 passed. So, okay, so let me remove this skip if here. So I commented that code. Yeah, you can see that 6 passed and it says 11 deselected. Okay, because we are not running those test cases. Yeah, total 17 items, 17 test cases. Out of the 17, 11 are deselected, 6 are selected. Okay, so it makes it much easier. If you don't have Pytest, you have to write some custom code. Okay, so you have to say this test case belongs to team A, the other one belongs to team B, and all that. But Pytest will make it easier for you with the different type of markers. Okay, and when you're running the test case, you can actually pass all these kind of different parameters to the Pytest so that you can choose how you want it. Okay, so now team B, I want -n4, okay, -n2, okay, 2 tests to be running in parallel. Okay, so you can mix and match any of these things. But yeah, that's an advantage of using Pytest. It can generate these nice reports in the end also. Okay, Pytest has some HTML integration. So here right now it's printing to the command line, but it also can generate a HTML web page. Okay, the HTML web page can show you like, hey, this test case failed. It failed at this line number, and if you click on the line number, it will take you to the code base. It can show you that, hey, this is where it's failing and all that. Okay. So there are some other additional plugins similar to Xdist that we did. Those can generate the HTML web pages also. Okay. So if you're running from Jenkins, it will be a nice HTML web page. If you click on it, it will show you a nice table saying that these many failed, these many succeeded. Here it is white failed and all that. Okay. But yeah, so that's Pytest. And Pytest is a third-party module. When I say third-party, it's not part of Python language. This is outside of Python language. That's the reason why we went to File, Settings, and install this additional package. Okay. Python itself has an inbuilt unit test framework, which is very similar. Okay, so let's quickly spend 2 minutes on Python's inbuilt framework. It uses object-oriented style. Okay, so okay, so there is a framework called unit test. Okay, so I'm going a little over the time because I kind of started late. But if you guys want to drop off, that's okay too. I understand. But yeah, so here I'm going to say something like test add. So Python's inbuilt uses object-oriented style. Okay, so here it's going to say unit test dot test case. So remember the base class derived class thing. So Python's inbuilt unit test uses object-oriented style. Okay, so any test case that you write or the class of the test case has to be derived from the unit test framework. Okay, so that means this is a base class and this becomes a derived class. Okay, and then we say test simple use case. Okay, assert add 2,3 or 5, or it's actually self dot assert. And this provides a lot of assert methods. Okay, assert equal add. Sorry, there should be assert equal. Okay, so I can say assert greater than add 10, 20 should be greater than 20. Okay. Oh, let me import the add method. So you can see that we are writing a class here, and the class is derived from this class, which is unit test or test case class. And there's a method called assert equal. And you guys can guess where this method is coming from. This method is coming from the base class, which is this guy, unit test or test case. Okay. So I can call various other methods, which is self.assert. You can see there is assert false, equal, is none, raises. Okay. This raises is also interesting because if you're expecting an error, so if I do add, let's say if I add an string and a number, that should raise an error. Okay. So you can say that it should raise an error. So that means assert raises. Okay. So you can put that assert raises and you can do that. Okay. So all this is provided by Python's inbuilt unit test framework. But here you can see that these parameters I have to pass individually. Okay. So in Pytest, it's like I declare this and I write a single line here inside the function. But here I don't have the parameterization. Okay, that means I have to specify each of those individually. And I have to say, am I expecting to be equal, greater than, or am I expecting an error and all that. It's a different style, but this is Python's inbuilt unit test framework. Okay, so if you look in the market, a lot of companies use Pytest than inbuilt unit test framework because inbuilt unit test. So let me run this and show you what happens. Yeah, inbuilt unit test doesn't offer options like running in parallel, picking and choosing which test cases do I want to run, like team A, team B, I want to run these test cases. So it doesn't provide those options. Or if I want to run in parallel, there's no choice for you. It will run all the test cases. Okay. So this runs in a different style. You can see that it says ran one test case and how long did it take? It took 0.003 seconds and it says okay. Okay means everything is okay. There's no error and anything. And you can see one dot means there is one test case. Okay. I can add another one, def test negative self.assert equal -2, -3. It's -5. Okay. Now there are two test cases. Okay. So anything that's starting with test underscore is going to become a test case. Okay. So you can see that it says ran two tests and everything is okay. Okay. That means everything succeeded. On the top, you see two dots. Two dots means those are two these things. Okay. If something fails, it's going to tell you what failed and so on. Okay. Assert equal 1, 0. Okay. So this is going to fail because I'm saying 1 and 0 are equal. So yeah, so you can see that the first one, F dot. F means one of the test case failed. The dot means one succeeded. And you can see why it failed, where it failed. It shows a line number, line 15. And inside the function test negative. And this is what the code base is. You are doing assert equal 1, 0, but it's saying 1 is not equal to 0. You are expecting them to be equal, but it's saying that they're not equal. Okay. So it says ran two tests, one failed. Okay. Failures equal to 1. That means out of the two, one failed. Okay. So it's a different output, but it will give you those same things like where it failed, why it failed, what is the reason for failure and all that. Okay. But it doesn't provide many options like parameterization, running in parallel, or marking the test cases and those kind of stuff. Okay. So in the industry, you will see mostly Pytest is being used. Okay. All right. Any questions so far? All right. So that, I mean, I wanted to have a session on database also. So maybe next session that we're going to go in deep in the database side. Okay. I mean, last time we saw SQL queries, but we never connected to database from Python. Okay. So I want to use Python to connect to database. There are many options. You can connect directly. You can use packages, third-party packages, and so on. So I want to go through that And then I also want to have some maybe testing on top of it. But yeah, maybe we'll cover that in the next session. For now, install the PostgreSQL. If you have any issues, we will look at those issues in the next session. For now, I want you to give you an assignment, small, so that you can practice in your free time. Okay. So first, I want you to write a function that can get the current time. And from the current time, or get the current date, or you know what, that can tell me whether a given year is a leap year or not. Okay, so if I say 2020, that's a leap year. 2024 is a leap year. Okay, but if I say 2023, that should tell, hey, this is not a leap year. Okay, so it should return true or false. Okay, so that is a function, is leap year or something like that. So you can name it anything you want, is leap year. Second thing, I want you to write elaborate test cases or test cases using Python, Pytest, okay, with parameterization and markers and all this, okay? So testing this function, testing is leap year. Yeah, you can have different, I would say, scenarios. I mean, I will leave it for your imagination, what test cases you want to run it for, okay? Next thing is write okay, convert that is leap year function to a class called year utilities and add another method. And this time the method should be is before World War I or yeah, is before World War I and add another method is before World War II and so on. Okay, so if I pass a year, let's say if I say 1850, okay, so that's before World War I, okay. But if I say in 1940s, that's after World War I, that should give me false. Okay, so true or false based on what you're passing. These are very simple methods. Okay, so you're gonna create a class year utilities, and you're gonna add different type of methods. Is it before World War I? Is it before World War II? Okay, so those kind of methods. Now test the year utilities with Pytest with various scenarios. Okay. Okay, so that would be the small assignment. I don't think this will take a long time. This should take less than 1 hour, 2 hours, but go through this. I mean, use Google search, ChatGPT, whatever you want to use. Make yourself familiar with the entire code, every statement, because the more you practice, the better it will be. I mean, even though you're not in Python automation, even though you're a Python developer, this will be helpful because every time you write some code base, you have to write the corresponding test cases. So this will be helpful for you. Okay, so try it out and let me know if you have any questions. Okay. What else, guys? Anything else?
Is next class same time tomorrow or
Yeah,
is it
next,
tomorrow?
Maybe, yeah, maybe not tomorrow. Maybe I will do it next week around Tuesday, Wednesday. But yeah, I'll let you guys know. Okay, so usually I give you like 48 hours notice so that you guys have some time to schedule accordingly. But yeah, I will let you know. But it's not going to be tomorrow for sure. And I'll send you the YouTube recording of this, so you guys don't have to record or anything. Once I upload this, it's going to take almost like 2-3 hours. So once that is done, I'll send you the link, and you guys can watch from there. All right, guys. So if you have any questions, let me know. I'm going to stop here for now. Okay, so let me stop the recording, and you guys enjoy your weekend.